As already mentioned, in order for an object to rotate within the gravitational field of another object, it needs its own rotational force, the magnitude of which must exceed approximately 0.64 of the strength of this gravitational field. Venus is located at the point where the strength of the Sun's gravitational field is as follows. The following rotational force is required to overcome this gravitational field. However, the rotational force of Venus is only as follows. Therefore, it cannot rotate within the gravitational field of the Sunday. If Venus cannot rotate within the Sun's gravitational field, it would have to constantly face the Sun with one side, similar to the Moon facing the Earth. In reality, however, it rotates in the opposite direction to the other planets, i.e., against the direction of its own rotational force. We must understand that no object can move forever without a force acting on it, especially in the Sun's gravitational field, which inhibits movement. But where does this force come from that causes Venus to rotate in the opposite direction? We have also explained that the orbital motion of the planets around the Sun is caused by the propulsion of the Sun's gravitational field. If we consider Venus as a point mass, the following orbital velocity around the Sun results. Since the strength of the Sun's gravitational field is different on the side of Venus facing the Sun and on the side facing away from the Sun, the following rule applies. Consequently, the orbital velocities of points A and B around the Sun, driven by the Sun's gravitational field, are approximately as follows. This causes Venus to rotate in the opposite direction. Its rotational speed can also be calculated simply by the difference between the orbital speeds at points A and B. For comparison, the rotational speed of Venus is actually about -1.8 ms. We need to clarify something here. Under the influence of the Sun's gravity, the orbit of a planet should be circular without the influence of external forces. This means that this result of -1.9486 ms was obtained on the assumption that the orbit of Venus was circular. This backward rotation of Venus is similar to a differential gear, a mechanism often used in mechanical engineering. When the angular velocity of the central gear, wheel 1, is greater than that of the outer gear, wheel 3, their satellite gears, wheel 2, rotate in the opposite direction.